Okay, do you guys see my slides? Anybody, do you see my slides?
Yes, we do.
Okay, very good. Very good. Okay, guys, before who's this? Okay, guys. Once again, good morning and welcome to Eeng261. Okay, this is the electrical and electronics. Okay, this is a semiconductor. We're going to study, the diodes, transistors, FET, Zener diodes, and everything. Okay, guys, the class hour is from 9:30 to 10:45. Okay, from 9:30 to 10:45. Okay. If you guys want to do good in this class, okay, this class is not very easy. This class is hard. Okay, very hard. Okay, it's not because it is hard. It's because the student they don't study. That's why. But it's not hard. Okay, it's not hard. Now, if you want to do good in this class, if you really want to do good, okay, come to the class, okay, early, okay, come early, sharp at 8 o'clock, because we're going to start at 8 exactly, okay, every day. Sorry, at 9:30. Come to the class at 9:30. Okay, do your homework. Okay, do your homework. Don't be late in your homework submission, and do your quizzes and study. Okay, study and pay attention when I explain things. Okay, pay attention. If you don't understand anything, raise your hand and say, you know what? I didn't understand this. Okay, can you go over it again? Okay, all right. And don't forget to submit everything on time. Everything should be on time. Okay, all right. Now we're going to start, the first chapter, which is semiconductor material. And then, we'll start with diode and then, application. Okay, so this is course overview, Eeng261. Okay, this is the first course in electronics. And I know this is your first class in electronics. And if you learn, if you study and learn this class, all the upper classes will not be very, very hard. Okay, but this is the foundation, guys. This is the foundation. So you have to do good. You have to study. Okay. So this class introduces semiconductor, electronic devices, and circuit. Okay, this is a prerequisite for Eeng262 and Eeng333. Okay, so you cannot take these classes before you finish this Eeng261. So the prerequisite for this class is Eeng100. You should have Eeng100, and you should have physics, of course, 102. Okay. This class has 3 hours, 3 credit hours. Okay, it involves 3 hours of lectures. Okay, and 1 hour of lab. Okay, probably each week. Okay, the course content. Okay, we're going to look at the semiconductor fundamental. We're going to look at the carrier transport and recombination, intrinsic materials, doped materials, and from the doped materials, we're going to produce N-type and P-type. Okay, and then physics and application of the P injection, that's the chapter number 3. okay, and then Zener diode characteristic and application. And we're going to look at the special purpose diodes, and then the fundamental of BJT, which is the bipolar junction transistor. And we're going to take look at the DC analysis of the transistor. And then we're going to look at the AC analysis. We call it, small signal, okay, circuit for the BJT. And we'll do the same for field effect transistor, or better known as FETs. Okay, so we'll look at the DC and the AC. Okay. Of course, we're going to solve a lot of problems and examples. Okay. Okay, textbooks. Okay, we have the main book. Our main book is Microelectronic Circuit by Sidra and Smith. Okay, Oxford University Press, 2011, 2012. Okay, and we have two reference books. One called, Circuit Analysis and Design by Donald Neiman. And this circuit is very, very nice book. This book is very nice book called Circuit Analysis and Design. And then we have another reference book called Electronic Devices and Circuit Theorem by Boylston. Okay, and this book is very easy book to read, very easy book to read and understand. Our book is hard to read, okay, hard to read book, but these two books are easy to read, okay. So if I were you, I will start with this, okay, and then with this, and then read our microelectronic circuit, okay. Okay, now we use in the past, long time ago, okay, we used to teach the students from this book, Electronic and Devices and Circuit Theory by Boylston. However, this is good, except this book doesn't have FETs. Okay, so that's why we didn't use it anymore, but we use it for if you want to study semiconductor, diodes, BJTs. Okay, this is a good book. Okay, but FETs, it's not good. Also, this book, cut corners sometimes. Okay, cut corners. Okay, so we don't want to cut corners anymore. Okay, all right. Okay, office hours. This is the normal time, but the trouble is, now we are in online, so office hours may be almost at any time. Okay, class hours. If you are in section 1, which is this one here, it will start from 9:30 to 10:45 a.m. and that's online. Okay, if you are in section 2, which is UTH, from 11 to 11:50 a.m. online. Okay. Okay, everybody. All right. Lab hours will start in 2 weeks. Okay, and we were going to use Circuit Wizard for our lab. Okay, now the lab. Okay, so what I want you to do is download the Circuit Wizard. Okay, download the Circuit Wizard and learn it. Okay, now if you go like this, if I will show you, if you download it, it will put a symbol like this. It will code Circuit Wizard. Okay, and if you click on it like that, okay, there you go. It will be like this. Very easy to read and very easy to implement. Okay, and you'll have here, the all the icon. Just go over and study it. Okay, this is the gallery. Okay, and this is the power supply connector. Okay, for example, this is the power supply like that. Okay, okay, and okay, instrumentation, op amps and stuff over there. Okay, this is the instrumentation like that. Okay, so this is the. Okay, so this is the digital voltmeter, and you have the scopes over here. Okay, scope over here. All right, and so on. Yes.
MATLAB. Can we
MATLAB.
use? Yes.
How can you use MATLAB? We want to use voltmeter. We want to use oscilloscope. Okay. I mean, how can you do that? Can you do that in MATLAB? You cannot use MATLAB. Okay. I want you to look at the waveform. Okay. You can use multisim if you want to. If you don't like this, you can use multisim. Okay, multisim is good too. Okay, so either multisim or this. This is very easy to learn. Very easy. Okay, very easy to learn. Okay, so probably if you do it legally, okay, you have to pay 18 dinars, I think, to do this. Okay, but I don't know. Okay, unless you have yes, go ahead. Go ahead. We'll come to that in a minute. Okay, we'll come to that. Okay, so wait. What is it? Oops, sorry. Okay, so sorry about that. Okay, so we'll come to that. Okay, so download, as I said, the Circuit Wizard or Multisim, okay, for our lab. However, what am I going to do is I'm going to put the slides, all the slides, all the videos for the lab, okay, how to do the labs, okay. That it will be what? It will be under files. Everybody see these files? Okay, this is it, files. Okay, if you click it, okay, you will see class materials. Okay, and then I'll put folders here. One called Eeng261 underscore, okay, lecture. One called Eeng261 underscore video. One over here called and so on. Okay, I'll put everything under. Also, I'll put the cover pages for the what. For example, or for the quizzes, but the quizzes come with the cover page. Okay, so I'll put it all under files. Everybody get that? Okay, good. All right. Okay, back where we are over here. Okay, amplify. All right. So don't forget to use this, okay, because this is what we're going to use. What we're going to use it for our lab. Okay, so you do your lab using this Circuit Wizard, okay, or multisim. Okay, midterms and final dates. Okay, we have one midterm. Okay, from 2 to 3:30 p.m. on 21st of April, okay, 2021. Okay, why did I pick this date, for example? Oh yeah, this date is because if you don't do good on this class, you will know that you didn't do good in the class. You have time to drop the class. Okay, the last date to drop the class is, everybody knows what it is? Anybody? 29, okay, 04, last date, okay, last date to drop the class, okay. The final is from 8:30 to 10:30 a.m., okay, and that's on the May 31st, right? Okay, check this number and you can check it on the UOB website, okay, just to confirm that this is correct, okay. Any questions? Okay. The weight, Okay, I will give you 6 homeworks. Okay, 6 homeworks, and they have 5%. Okay, of the total, of course, right? And then 5 quizzes. I will give you actually 6 quizzes. Okay, but I will take only 5 out of the 6 quizzes. Okay, I will take the best 5. Okay, the best 5. So if you didn't do good on one of them, doesn't matter. Or if you are absent on one of them, it doesn't matter, right? I will take 5. Okay. Okay. And they have 15%, of course, of the total. And the 4 labs experiments, they have 10%. That's we will use circuit wizard, as I said before. And one midterm exam will have 30%, and the final will have 40%. Okay, so as you can see from here, okay, to midterms, you have 60%. So I'll post this 60%, of course, just before the final, so you can see, where you are. Okay. As I said before, okay, no late homework or lab or quiz or exam are accepted. Okay, you're going to lose a lot of mark if you are late. Everybody understand that? Okay, no makeup exam. Okay, if you miss midterms, you will lose 30%. Okay, department policy, you will get an F if you caught cheated. Okay, if you caught cheating in the exam, you will get F. You are not allowed to use cell phone in the exam. You are not allowed to use Solver. I don't want anybody to use Solver, okay, which is the big Casio, okay, probably I call it mini computer, something like that. Don't use Solver in the exam, okay. I wouldn't mind you to use, okay, I wouldn't mind you to use Casio FX-991, okay, ES plus, okay. This is simple calculator, scientific calculator, and you can use it, okay. You can use this, very good calculator, okay. All right. Another thing is I want to say that if you are repeating the class, okay, you didn't have to repeat the lab. Don't repeat the lab, okay? Okay, now, how do I know, okay, that you didn't have to repeat the class? I didn't know, okay? So what you have to do, every time I give the student lab, okay, and the student submit the lab after, say, 1 week, submit the lab, all I want you to do, take a paper and write your name on it and write your ID, okay? And for example, experiment number 1, okay? And the date that you took the class or the year that you took the class, okay? And then, just submit it with the students, but you didn't have to do the lab. Everybody get that? For the student who just asked about that. Any questions? Any questions? No questions? Okay. All right. Homework, okay, will be assigned, say, start, for example, Tuesday, for example, 2021, due to 12 p.m. following Tuesday. If you are late, okay, 5 minutes late, it will not be accepted. Okay, so make sure that you submit the homework on time. Okay, on time. Okay, so if I were you guys, I will submit the homework long before the due date. Okay, long before the due date. Okay, all right, very good, very good. Also, what I would like you to do, also when you write your homework, your quizzes, your exams, I want you to use blue pen, okay? Blue pen. I don't want you to use to black, no black pens, okay? If you use a black, I will detect at least, 3 point or 4 point or something like that. Use blue pen. Everybody get that? Okay, very good, okay? The homework cannot come with the cover page on top, okay? Write your name, your ID number, course and section, okay? Homework number of problem you solve, and date, okay? The cover pages for for the exam, quizzes, homework, okay, or labs, okay, have to be included. If you don't include the cover pages on these, you're going to lose marks. Okay, so don't lose marks because silly. Hey, you guys, I'm going to post under files, okay, cover page for example, for the quizzes or for the exam or something like that. But the quizzes will come with the cover page, homeworks will come with the cover page, and so on. Okay, one thing before you start this class, guys, go and buy a printer, okay? Printer. I mean, it's not expensive. I found a printer, yesterday in Carrefour, this HP printer. How much? 10 dinars. Okay, 10 dinars. Okay, so if I were you, I will go and buy one. Okay, so it's only 10 dinars, guys. Okay, buy one. Okay, it's better than later on you will lose mark, and then at the end you will say, okay, well, I'm going to do well, تظلم will cost you 10 dinars, right? Okay, so instead of doing that, buy printer. Also, make sure that your internet, okay, is good. Okay, your internet is good. If your internet is bad, okay, well, you're going to lose a lot of money. You will not be able to submit. Okay, so don't tell me, my internet is bad. That's it will not be accepted. Okay, make sure that you have good internet. You don't have good internet, you didn't have a printer, you didn't have anything, drop the class, take it some other time. Okay, next semester we offer this course every semester. Okay, so be prepared, guys, be prepared. Okay, if you study, hey guys, if you want to get an A in this class, you have to come early. Okay, you have to understand the material, the slides, ask questions, okay, and practice solving problem, okay, and read the books, okay, read them, okay, and understand. If you don't understand the book, go into internet, okay, and they have so many people, talk about, electronics and stuff, okay, especially YouTubes, okay, and get more knowledge. Okay, guys, and that's how people get an A, because people who are study, they will get an A. People who do not study, they will not get an A. Okay, and I have seen people, so many people, get an F. I say, guys, I don't want you to get an F in this class. Okay, all right. As I said here, no late homework or reports are accepted. Okay. Any questions so far? Okay. Any questions? Any questions? No questions? Okay. So we're going to start. Okay. We're going to start on chapter 1. Okay, which is semiconductor and diodes. Okay. This is 1.7. This is a concept and intrinsic semiconductor. Okay. 1.8, doped semiconductors. Okay, doped semiconductor. So don't worry about, you know, doped and intrinsic and stuff. We'll go over it, you know, in a minute or maybe later. Okay. 1.9. This is the current flow in semiconductor. Okay, 1.10. This is the p-n junction. Okay, within open circuit terminals and stuff. And then 1.11, the p-n junction with applied voltage. Okay. Capacitor effects and the p-n junction, we just go over it. You know, I'm not going to, you know, stay on it for a long time. But, you know, I will give you just a brief description. Okay, because if you are going to continue studying your major in electronics, you need to understand this as well. Okay, any questions so far? Okay. Semiconductor materials. Okay, this is on slide number 9. Okay, semiconductor are special class of elements having a conductivity between that of a good conductor and that of an insulator. And they come on single crystal, okay, in nature, and compound. This is man-made. Okay, the three semiconductor used most frequently in the construction of the electronic devices are the first one, germanium. Okay, germanium, and the diode was invented in 1939, long time ago. Okay, and the transistor in 1947. So, you know, this is the first semiconductor material, germanium. Okay, and germanium material works very well, very, very well. Okay, at room temperature. However, as the temperature varies, then the germanium, whether a diode or transistor, will be not reliable. It will not be reliable for, you know, when the temperature varies. What does that mean? It means, you know, when you go into Sahara Desert, where the temperature is, say, 60 to 70 degrees centigrade, the germanium doesn't work very well. Or when you go to the South or North Pole, where the temperature, you know, is, say, 50 degrees below zero, then the germanium will not work very well. Okay, we need something to work, whether, you know, the temperature is minus 50 degrees, or the temperature is 150 degrees C. We need the circuit works. Why? It's because, you know, the electronics components, okay, such as microprocessor, microcontrollers, okay, diodes, and so, okay, we're going to put them in airplanes, rockets, okay, spacecrafts, okay, where the temperatures are extreme, okay, and they should work. You got it? Okay, so the scientists, okay, they said, you know what, we're going to look for another materials, such as, okay, silicon. So the silicon, okay, works very reliably in extreme temperature, whether, you know, minus 50 or 60 to plus 150 degrees or 160 degrees centigrade. Okay, remember the water boils at 100 degrees C. Okay, and the circuit still works. Okay, and therefore, you know, the silicon here, all the components made of silicon, we are using them now in our cell phone, our laptop, in our TV, in our desktop, in our refrigerator, in our, okay, everywhere. Okay, and airplanes and tanks and rockets and spaceships, everything are made of silicon. Okay, very good. Now the silicon is good. Okay, but then the speed of the microprocessor okay, for example, such as, you know, P5, P7, okay, they have a normal speed of 3 to 4 gigahertz. Okay, now the silicon doesn't catch up, okay, slow at this speed. I mean, compared to the microprocessor, we need something very, very fast. Okay, well, there is a way to do it in silicon, you know, I mean, okay, but it's not direct, okay, cope with the speed of the microprocessor. So we need something a little bit faster, okay. So what happened is that the scientists came and they take gallium and arsenide, put them together, and they created a compound, the compound called gallium arsenide, okay. There is a company in Hillsboro, Oregon, that deals with the gallium arsenide, okay, and the gallium arsenide works just like the silicon, except, you know, it's 5 times the speed of the silicon. However, this is in its infancy, so the technology is not mature. Therefore, you know, it's very expensive. Okay, very expensive. The company that's pioneering in this called Triquant. Okay, and this is for Oregon. Okay, Triquant. Okay, now, and that's why, you know, we didn't use it. You didn't use it anywhere actually, you know. So, but you know, it's very fast. Okay, faster than the silicon, 5 times faster than the silicon. Okay, now what we're going to do, we're going to study, you know, we look at the atomic structure, okay, of the silicon, okay, gallium arsenide, gallium and arsenide. Okay, we're going to look at the atomic structure. Okay, remember that atomic structure, you know, called electrons, protons, and neutrons. Okay, we call this Bohr model. Okay, now to the left you have the silicon atoms here. Okay, you have the nuclear here. Okay, it has a neutron and protons, and has 3 outer shells. Okay, and has in its outer shell there are how many electrons? 4 electrons, and we call those valence electrons. Okay, valence electrons 1, 2, 3, 4. Okay, likewise the germanium also, you know, has 4 electrons in its outer shells, and we call this, you know, tetravalent. Okay, tetravalent. Okay, 4 electrons in the outer shell. Notice that this germanium has how many shells? 4. Okay, compared to the silicon has 3 shells. What does that mean? It means that the outer electrons for the germanium can be detached easier than the electrons of the silicon here. Is because, you know, the silicon is very close to the nucleus here. Okay, and therefore it requires more energy to detach it from from its atom, while here required less energy because, you know, it's away from the nucleus. Everybody get that? Okay, we took this in where, in physics or chemistry, you know, when we were in high school. Okay, now gallium. Okay, gallium, on the other hand, has 3 electrons in its outer shell. Okay, 3 electrons. Okay, and we call that trivalent. Don't worry about the name, but, you know, we call it trivalent. Okay, 3 valence electrons in its outer shell. While the arsenic have 5 electrons in its outer shell, and we call that pentavalent. Okay. All right. So we're going to use these. Okay, we're going to use gallium or arsenic. Now, if we look at the at the periodic table here. Okay, everybody knows periodic table. Yeah, we took this in high school. Okay, as you can see here, group 3 is gallium. Okay, boron. Okay, aluminum, and so on. Indium. Okay, while this here, this is group 4. You have the carbon. Okay, you have this silicon, and you have the gallium. We have the germanium, sorry. Okay, Ge. These are group 3. Okay. Over here we have what? We have arsenic, phosphorus, and so on. Okay. So these are group 5. These are group 4. And these are group 3. Okay. Any questions so far? Any questions? Okay. Now, if we are looking at the pure crystal of silicon, I mean very pure. Okay, we can see this is what is it? This is two-dimension, 2D picture. Okay, this is perfect. You can see that's the atoms here. Okay, these are the nucleus of the silicon. Okay, and you have see each silicon, okay, shares 4 electrons with the neighboring 4. Okay, for example, this one here will share its 4 with with this one. Sorry, which shares 2 electrons with this one, 2 electrons with this one, 2 electrons with this one, and 2 electrons with this one. Okay. Remember that the nucleus has 4, okay, plus 4 because of the 4 electron outer shell. Okay, and this one here, you can see this one when the temperature is what is very low, is 0 Kelvin. Okay, 0 Kelvin. Okay, you can see that the pure crystal is formed like this. Okay, and if you notice that there are no electrons wandering around, there's nothing. Okay, so now at this temperature, which is 0 Kelvin, very cold, the silicon acts as insulator. Okay, it will act as insulator. It's because, you know, we don't have any carriers. Okay, everybody get that? All right. Okay. Now this is at as you can see here, this is at 0 degrees Kelvin here. Okay, no carriers. Okay, everything is locked, and you can see that, you know, each atoms here, okay, which is called plus 4, has shared 2 electrons with the neighbor, 1 electron with this, 1 electron with this, 1 electron with this, 1 electron with this. Okay, and the this atom will see how many electrons. We'll see 8 electrons. Okay, and its valence, so it will be very stable. Okay, this is at 0 degrees Kelvin. Okay, over here, okay, I said here intrinsic. Intrinsic is applied to any semiconductor materials that has been carefully refined. Okay, what does that mean? It means, you know, the number of impurity is very, very low. Okay, it's very low. Okay, and this one here is made by, you know, of course, you know, modern technology. Okay, they purify it so that, you know, the impurity in the semiconductor is very low, and we call this intrinsic. Okay, very pure semiconductor. Okay, any questions so far? Any questions? Okay, okay, covalent bond. or covalent bonding? A covalent bond is a chemical bond that involves the sharing of electrons pair between atoms. The stable balance of attractive and repulsive forces between atoms when they share electrons is known as covalent bonding. Okay, it's a chemical bond. Okay, so that's why they call it covalent bond. So this one here is where is the covalent bond? Is this here? Okay, this one here. This is covalent bond. Okay. All right. This is again. Okay, we are looking at the pure crystal, silicon crystal here. Okay, so at room temperature, okay, we are not talking about the we know that 0 Kelvin temperature, okay, which is what 270 degrees C. Okay, the pure silicon will act as insulator. Okay, as the temperature rises, okay, so at room temperature, some of the covalent bond breaks. Okay, so breaks, and then when the covalent bond breaks, you will see electrons wandering around, and that's good for to be used for to conduct electricity. So at room temperature, the silicon crystal, pure silicon crystal, will act as a conductor, as a conductor. Okay, got it? And conductor. Is it good conductor? Well, it's not that good, but it's a conductor. It can conduct electricity. Okay, remember that when one electrons move away from its atom, it will be replaced by something called holes. Okay, holes. Okay, and the hole is the same as the electrons, except it's positive instead of negative. Okay, so electrons has negative charge, while the hole has positive charge. Everybody got that? Okay. All right, guys. Okay, as I said before, we have at room temperature, the silicon crystal, pure silicon crystal, will act as a conductor, but at 0 Kelvin will act as insulator. Well, that's not good enough for us. Okay, we don't want to rely on the temperature. Okay, we don't want to rely on temperature. So how are we going to improve, okay, the conductivity of the silicon? Okay, how are we going to do that? Okay, we do that by introducing a material or impurity to the pure silicon material. Okay, and before we do that, we have here called extrinsic. Remember that intrinsic is pure. Extrinsic means that the semiconductor material has been subjected to doping process. Okay, doping process. What does doping process means? Means we took some materials and materials impurity other than silicon, okay, and we introduce it in, or we put it in the silicon, pure silicon itself. Why do we do that? It's because we want to increase the number of the carriers, okay, in it, okay, and the pure silicon. Okay, guys. Okay, so what happened is that we're going to create something called N-type materials. Okay, N-type materials. Okay, and N-type materials we call it. Okay, how are we going to do that? We take either antimony, okay, from group 5 in your periodic table. Remember that, or arsenic, or phosphorus. Okay, phosphorus is pentavalent. Remember pentavalent? Arsenic is also pentavalent. Antimony is also pentavalent. So one of these we take impurity from these materials, and we're going to introduce it to the pure semiconductor, carefully measured. Why? because we want to know, we want to carefully introduce this. The amount of the impurity is measured carefully by a computer, okay? So the computer will measure it, will drop this material, either phosphorus or arsenic or antimony, on the pure semiconductor material, and then it will spin it, okay? Spill the material, and then we'll wait, and then, you know, the antimony or phosphorus will dissolve, okay, in the pure silicon crystal, okay, as you can see here. Okay, so so what we did, we took phosphorus, for example, okay, and we put it in the pure semiconductor material, okay, silicon material, for example, okay, and because we did that, the phosphorus atom has how many electrons? 5 electrons. Have 5 electrons. Okay, so it will share 4 electrons with the 4 neighbor atoms. Okay, and one of the fifth one, it will just wander around. So imagine, you know, we have billions of these, okay, floating around, and that's good for conducting electricity, okay? And we call this material, which is the phosphorus now, okay? We call it donor atom. What do you call it? Donor atoms, okay? This material here, which is the phosphorus, okay? Why we call it donor atom? It's because it donates electron, okay? 1 electrons to the semiconductor material, which is in this case silicon. Get it, guys? Call it this, okay? And after we do that, do that, the end product, okay, the end product, we call this N-type material. What do you call it? N-type materials. So the N-type materials, you will see that the majority carriers, okay, are electrons. Everybody get that? The majority carriers are electrons. Okay? Any questions? Any questions? Okay, so we created N-type. Okay, now what we're going to do, we want to create another type, okay, called P-type. I guess, you know, the what they call it N-type is because, you know, the carriers are negative, right, which is our electrons. Okay, so that's why it's called N-type, okay, instead of calling it negative, N-type. Okay, now what we're going to do, we're going to create P-type. Okay, I put more information. I added more information from the internet. You know, this is shows you the same thing as this here. Okay, this is the phosphorus. Okay, impurity or phosphorus materials atom introduced in the semiconductor, and you can see that 4 electrons are shared with the 4 neighbor electrons of the silicon, and 1 is floating around. It's good for conducting electricity. Okay, all right. Now what we're going to do, we're going to create a P-type material. Okay, we're going to create P-type. Okay, so the P-type material created by, we take impurity or element, impurity element from the group 3, such as boron or gallium or indium. Okay, so we take boron, for example, material, and carefully measured, and we introduce it to the pure silicon crystal. Okay, and we'll wait, and then, you know, after some time, the boron material will dissolve, okay, in the silicon, and since the boron atoms, okay, have 3 electrons in its outer shell, it will share 3 electrons with the neighbor 3 silicons materials, atoms, but you know, one, okay, is missing. So it's missing here, electrons. So what happens is that this one here, we call this missing electrons is a hole here, okay? And the hole doesn't stay very long. It will wander around because, you know, the hole here, this electron will jump over here. So it will be over here. The hole will be here. So the hole will be also good conductor for electricity, okay? And we call this material, which is in this case the boron, okay? We call this acceptor atoms. Why? Because it accept electrons, okay, coming from somewhere, okay? We call this acceptor. We call this impurity trivalent electron impurity, okay? Okay, guys, so we call this acceptor, okay, atoms. All right, and the majority carriers and the end product, which is the p-type now, created a p-type, are holes, okay, holes. That's the majority carriers and the p-type. Okay, guys? Any questions? Okay, so we created n-type and we created p-type. As you can see, as in slide number 8, this is the another version. You can okay, if you want to, if you don't like this one here on slide number 17, on slide number 18. Okay, this is from the internet. This is the new one. Okay, this is the boron atom, and you can see it shared 3 electrons with the neighbor, and the 4th one, you know, it's missing. So this is called holes here. Okay. Is there any questions? Any questions? Okay. Okay. So, okay. Now the holes moves, you know, say for example to the right, okay, and the electrons move to the left. Okay. Holes. Okay. Okay, and electrons, or you know, or vice versa. Okay, vice versa. Okay, or electrons and holes. They move opposite to each other. Okay, the conventional current is always, you know, the conventional current is with the holes, you know, going to opposite to the flow of the electrons. Okay, that's the conventional current. Okay, is there any questions so far? Okay, now I didn't tell you all the stories. Okay, and the n-type, the majority carriers are electrons. Okay, and p-type, the majority carriers are holes, indicated by the plus here. Okay, you can see it's a lot of pluses, while the n-types a lot of electrons. Okay, now in each type, which is the n-type and the p-types, okay, materials, there are, okay, a number of minority carriers. What are they? In the n-type materials, okay, the majority carriers are electrons, but the minority carriers, very few, minority means very few, are electrons. Sorry, are holes. Okay, so the majority carriers and the n-types are electrons, and the minority carriers and the n-types are holes. Okay, are holes, and the p-type, the majority carriers are holes, but the minority carriers are electrons. Okay, everybody get that? Any questions? Any questions? Okay, no questions? Okay, so what you're going to do since we start, you know, I mean, this is the first day. So I'm going to stop here. I'll let you go, and then we'll continue on Wednesday. Is there any questions I can answer? Any questions, guys? So we stop at 20, okay? Any questions? No questions at all? Okay. Okay.
Excuse me, Doctor.
Yes.
We
ahead.
want the code for joining this team.
You are joining. You are in
No,
this team.
for somebody else in the group.
What does that mean? Did I miss anybody? I didn't miss anybody. I put all the names in here. If you want this thing, a code, I will generate a code and then I'll post it. Okay?
Okay, okay.
All right. Remember that I don't want anybody from outside who hasn't registered to this class to be in. Okay? That's against the university policy. Any other questions? Okay, we'll stop recording.